everyone, so we're going to look at some examples of using the method of completing the square to solve quadratic equations, and hopefully you've watched the video from yesterday's lesson which would take you through how to actually complete the square on a quadratic expression. But for this first one, we'll do that again today. We'll do that as part A, and then we'll look at actually solving a quadratic. So let's have a look at this. So the first one, right, this quadratic's got an x squared in it, x squared plus 4x plus 3 in this form. So we want a squared bracket plus some number at the end. And this might be plus or minus, and this might be plus or minus. Okay, so let's have a look at that. And the way that we start this method is we ignore the plus 3 for now, and we just look at the x squared plus 4x. And what we do here is we halve the coefficient of x. So we look at the number in front of the x and we just halve that. So that would give me plus 2, positive 2. And the sign is important here. So I look then at doing x plus 2 squared. So I'm replacing this part, this green bit, with x plus 2 all squared. Okay. And for this first one, I'm going to square this bracket out just to confirm how this works. And then for the others, the next 4 examples we do, I'll skip this step out and we'll just move through the method. Okay, so x plus 2 all squared is x plus 2 times x plus 2. FOIL rule for this then, so that's going to give me x squared plus 2x plus another 2x plus 4. So x squared plus 4x plus 4. And what I want here, I want x squared plus 4x. So I'm ignoring the 3 completely. So I'm just looking at this expression. So I want what I write here to be equivalent to this. So x plus 2 squared gives me this. So if we look at that, I want the x squared. I want the plus 4x. But for this green part, I don't want the plus 4. So I'm going to need to take 4 away to make sure that I'm just left with x squared plus 4x, which is what I want here. So that's going to give me minus 4 here to get rid of this plus 4. And that now, if I expand this and take 4 off the end, I'm left with this expression, x squared plus 4x, which is what I want. And then I've got to remember this plus 3 at the end of all of this. So plus 3 there. So what do I end up with? X plus 2 all squared, minus 4 plus 3 is minus 1. And that's my completing the square method. Okay, so you get a square expression, a bracket squared, and then some other number on its own afterwards. So I've done part A. Part B then now is asking us to solve this. And this word here is important. If you see this word in an exam question, hence, it means you have to use the method that you've done in the first bit of the question. If it doesn't say hence, then you could use some other methods if you wanted to here, but this says hence, so we have to use what's gone before. Okay, so we're looking to solve x squared plus 4x plus 3 equals 0. So I can replace this left-hand side now with this part A expression. So that's equivalent to x plus 2 all squared minus 1 equals 0. And now I'm solving this. And solve means find the x value or the x values. So I want to get x on its own. So now I'm looking at changing the subject here, rearranging this. So the first thing to do is to get rid of that minus 1. So let's add 1 to both sides. So that's going to leave me with x plus 2 squared equals positive 1. And I can't get rid of this 2 yet because it's been held in this bracket by this squared. So the next thing to do is to get rid of this squared. And the opposite of squared is square root. So what I'm going to do, I'm going to square root both sides. So this will get rid of the squared, so that'll give me x plus 2 equals, and on this side, the square root of 1. Well, that's quite nice because the square root of 1 is just 1. Now at this point, I'm going to stop and go back a stage because here, what happens here, when you square something, okay, it doesn't matter if it's positive or negative. So here, for this thing to be equal to 1, it could be the square root of 1, or it could be the negative square root of 1. So we need a plus and minus on there. Let me just put a plus minus on there. So that means that this x plus 2 could be 1, positive 1, or x plus 2 could be negative 1. And if we think about that, if I square both sides here, that's going to give me x plus 2 squared, which is correct, 1 squared, so positive 1 squared is positive 1 times positive 1, which is 1, and negative 1 squared is negative 1 times negative 1, which is also 1. So these definitely give me the same thing when I square them, so I've got to make sure I'm including both of them. Okay, next thing to do then is to get rid of this plus 2, so let's take 2 off each side. And then I'm going to end up with x plus 2 equals this negative 2 plus or minus 1. Sorry, not x plus 2 because I got rid of the plus 2. So x equals minus 2 plus or minus 1. And then I'm going to write that out as two solutions. So x is minus 2 plus 1, or x is minus 2 minus 1. So final answer is minus 2 plus 1 is minus 1. Minus 2 minus 1 is minus 3. And there's our two solutions. And we were expecting two solutions because it was a quadratic we were asked to solve. So that's our first example. I'm not going to go through this part in the next examples, but you can always do this part to check. So we're going to go through a few more of these in the next few examples. What I'd like you to do though with this is to stop the video here. You might need to replay this again just to convince yourselves of this method. But I'd like you to get this example into your notes as well. Okay, let's have a look at example 2. So, example 2, not an A or a B this time, just straight into use the method of completing the square to solve this. So because it says this, we have actually got to go through this part A ourselves. So it's a multi-step question. They're not going to tell us to write it in this form. They're just going to assume that we know what completing the square means. So we're going to do this part, and then we're going to do this part, all within the same question. Okay. So completing the square first of all. So let me just write this out on this piece of paper. So we complete the square on this part of the expression. Keep the plus 1 there, just ignore that for a minute. So that's going to be x plus half this coefficient, so half of 4 is 2, squared. And if I square this out, I could do that, but as I say, I'm not going to do that now. You can do that if you want to. If I square this out, I'm just going to pull my other question back. It starts off the same as this, x plus 4 squared. What I need to do is to take 4 off the end, because 2 times 2, when I do the last part of this FOIL rule, 2 times 2 gives me 4. So I need to take 4 off because I've got 4 too many there. So let's take 4 off there. So basically what you do, you square this. 2 squared is 4. So I've got 4 too many, take that off. And then I need to remember that plus 1. So that's going to give me x plus 2 squared minus 3 equals 0. So x plus 2 squared equals 3. Now, so by adding the 3 on both sides, now I'm going to take the square root, and don't forget that plus or minus idea. So x plus 2 is now the positive or the negative square root of 3. Now, if this was on a calculator paper, I might do this on my calculator, and the question might say give your answer to 1DP or 3SF, but this isn't. This is going to be a non-calculator question, so I'm going to leave my answer in surd form. So the last thing to do is to take this 2 away, to get rid of it. So x equals minus 2 from both sides. Just write that underneath. So there I added 3. Here I did square root, plus or minus square root. And then here I'm going to take the 2 off both sides. So that's going to leave me with x here, and then minus 2 plus or minus the square root of 3. So I'm just going to write them out separately as my two solutions. Minus 2 plus root 3, or x equals minus 2 minus root 3. So there's our answer to that question. Okay, next one, question 3. So question 3, same idea, let's solve this. Slightly more difficult here, only because the number multiplying the x, the negative 3, doesn't divide by 2 easily. Or doesn't give us a whole number. It does divide by 2 easily, but doesn't give us a whole number. So let's just go through this one as an example in our notes. So I'm completing the square on this part. So that's going to give me x minus half this, so 3 over 2. Or you could write that as 1.5, but 3 over 2, I'm going to leave it like that because it's easier to square that way. So x minus 3 over 2, all squared. And if I did FOIL rule on this, then my final term is going to be minus 3 over 2 times minus 3 over 2. So that's going to give me minus times a minus is a plus, 9 over 4. So I've got 9 over 4 too much that I need to get rid of, because when I square this out, I'm going to end up with this. I want to get rid of that. So I'm going to subtract that from here. So we always do that. It's always subtract, because this number will always be positive. So x minus 3 over 2 minus 3 over 2 squared is plus 9 over 4. So take that away. And then don't forget our plus 1 here. That equals 0. Let's tidy these numbers up. So x minus 3 over 2 squared minus 9 over 4. And then let's put that over a common denominator. 1 is 1 over 1. So over 4, it's going to be 4 times 1 is 4. So x minus 3 over 2 all squared minus 5 over 4 minus 9 plus 4 is minus 5. Take the 5 over 4 and add to both sides. So that's going to leave me with x minus 3 over 2 squared equals 5 over 4. Keep on going with this. Plus or minus the square root now to get rid of the squared on this side. So x minus 3 over 2 is plus or minus the square root of 5 over 4. Now at this point again, I can leave this like this, but I can see here I've got a nice square number in the denominator. So actually I can rewrite that. That's the same thing. Square root of the whole fraction is root 5 over root 4. And the square root of 4 is quite nice now, because that's a nice whole number. Instead of it being a surd, it's an ordinary number, so I can do that. So let me just tidy this one up. So that's going to give me plus or minus root 5 over 2. And then add 3 over 2 to both sides. And I'm going to end up with x equals positive 3 over 2 plus or minus root 5 over 2. So again, I'm just going to move that up. Let's just write that out. Our two solutions, 3 over 2 plus root 5 over 2, or x equals 3 over 2 minus root 5 over 2. And that's example 3. Example 4. So let's look at this one, example 4. Now it's a bit more difficult. It doesn't look particularly more difficult, but these ones now with completing the square, and you will have seen this if you've watched yesterday's video. If we haven't just got x squared at the front, you know, in all of these other ones we just had x squared, so you just need an x in your bracket. If we haven't got just one x squared here, we need to take the 2 out here as a factor of this expression. And again, we're only going to be looking at this part of the expression. Leave the plus 13 alone, we'll put that back in at the end. So this bit to begin with is going to give me 2 brackets x squared plus 6x. Let's add our plus 13 on there so we don't forget it. And now I'm going to complete the square on this bit in the bracket, but you need to make sure you're careful with these brackets. So let's leave the 2 outside the whole thing. Then completing the square on this is going to give me x plus 3, half this, squared. 3 times 3 is 9, so I need to take a 9 off the end of that. So that's completed the square of this part, and then I mustn't forget my plus 13 at the end. Okay, so now let's sort this out. We've got 2 lots of x plus 3 squared. 2 times minus 9 is minus 18, plus 13 is 0. And I'm not going to multiply this out. The danger sometimes with this is people go, oh, there's a bracket to multiply out there, I'll do FOIL rule. If I do that, all that's going to happen is I'm going to get right back to this expression in the question. So make sure you remember, with completing the square, I want this squared bracket in there. That's the whole point of this method. So 2 brackets x plus 3 squared minus 5 equals 0. Let's take that 5 and add to both sides. And then I'm going to divide by this 2 because I want to keep this square bracket here. So let's divide by this 2. X plus 3 squared equals 5 over 2. Plus or minus the square root to get rid of that squared. There isn't a nice square number here, so I'm going to leave that like that. Let's take the 3 away. So minus 3 plus or minus root 5 over 2. So x is equal to minus 3 plus root 5. Sorry, that should be a big square root, plus root 5 over 2. Or x is equal to minus 3 minus root 5 over 2. Okay, and there's our solutions to that question. Last one. So let's have a look now at this last question. We're almost there. So this last question, it's a really important one, this actually. Again, it doesn't look very different to the others, but what we haven't got here, we haven't got equals 0. And whenever you're solving a quadratic by doing any sort of factorisation or completing the square or anything like that, we have to have equals 0. So I need to rearrange that first to give equals 0 on one side. So it doesn't matter which side when you're doing these, but I'm going to collect my x squareds here to keep the x squared term positive. But it would work the other way as well. We'd just have some negatives to try and sort out. So I'm going to, in this question, we've got 3x squared equals 6x plus 8. So I'm going to, as my first step, take the 6x away, take the 8 away on both sides. So that's going to leave me with 3x squared minus 6x minus 8 equals 0. And now I've got a quadratic to solve. So first thing to do in this method that we're doing at the moment is to take this 3 outside as a common factor. And we're just looking at this bit, don't forget. So 3 outside is a common factor because I just want to have one x squared there. So x squared minus 2. Now I haven't got a square bracket yet. Sometimes again people get a bit confused here and go, oh, I'll just take the 8 over at this point. I'm not ready to do that yet because I haven't completed the square here. It needs to be in a bracket. It needs to be a whole bracket squared. It's not good enough to just kind of carry on with this bit, so it needs to be a whole bracket squared. Okay, sorry, I've just seen I've missed an x there. So let's just do that. So I've taken the 3 outside, x squared minus 2x, that's going to give me 3x squared minus 6x, that's right now. Got to complete the square on this. So 3, let's just put a big bracket there. Half of minus 2 is minus 1, so x minus 1 all squared. Then at the end of this, it would give me minus 1 times minus 1, which is plus 1. So I need to get rid of that plus 1 from my FOIL rule. And then we've still got this minus 8 from the start question in there. Start the question, still got that minus 8 to deal with. Let's multiply in by this 3. So 3 brackets x minus 1 all squared. That's fine, that's what I want. Minus 3 minus 8 is 0. So 3 brackets x minus 1 all squared minus 11 is 0. And now let's sort this out, rearrange, make x the subject, take the 11 and add to both sides. So 3 brackets x minus 1 squared equals positive 11. Take the 3 across. Almost there now, so now I've got this squared in my way, so let's do plus or minus the square root. Sorry, let me just move that up. So x minus 1, let's get rid of the squared by doing plus or minus the square root. Again, not particularly nice numbers to square root, so I'm going to leave that as it is. And then let's take this 1 over and add to both sides. So x is equal to 1 plus or minus that square root. So x is equal to 1 plus root 11 all over 3. Or x is equal to 1 minus square root of 11 over 3. And there's our 2 answers. So that's 5 examples we've done there. I'd like you to get them into your notes, and then I'm going to give you an exercise to do on this topic.